to our university. This is the first step towards starting your program here at the university, or at least the first time that you get into contact to people who are implementing the actual program. Where are you? Where are we? We are talking about the Master of Electronics and ICT Engineering Technology, and it is located, and I have to skip to another screen. It's located in the Faculty of Applied Engineering, and then specifically in the Department Electronics and ICT Engineering Technology. And then maybe it's important to know who I am. I'm the head of that department. So I'm professor at the university, and I'm also leading the program that you are subscribing for. I will start with some generic information about the programs we have in the faculty, and then we go a bit more into depth into the program you have, and then afterwards there is room for a lot of questions if you have them. So first things first, when you look at our faculty, we have 4 different kind of master programs, but to get there, all of our students start with what we called a joint bachelor degree. But a joint bachelor degree means that half of the credits you spend on like common courses, and then the other half is really focused on the domain you are studying in. And we have 4 domains there. We have chemical engineering technology, we have civil engineering technology, we have electromechanical engineering technology, and then our department focuses on electronics and ICT engineering technology. When people graduate from that bachelor, they get direct access to the master, and it is the master that you're also subscribing for. No, now we have more than one master, of course. Based on what you saw in the bachelor's, when you go to the master, you can subscribe for biochemical engineering technology or chemical engineering technology, which are both in the department of chemical engineering. Then there is a master in civil engineering, there is a master in electromechanical engineering technology, and then there is our master in electronics and ICT engineering technology. And that is why you're here. You did not do our bachelor, but because you filed your documents and your application form, we screened you, and based on the competences that you described in those documents, we decided that to grant you access to our master program, on which we will focus a bit more now, and which is a 1-year program. So let's go to the next slide. If we look at our master program, there are different parts in there. First of all, there are 27 credits. Credit is a thing that I will, it's a unit in describing how big a course is, and I will elaborate a bit more on that later. But we have 27 credits that you will spend with all other master students. Those courses that you will get there are deepening a bit the core competences that every engineer, electronics and ICT engineering, should have. First of all, we have like 6 credits diving into electronic systems. Then we have 3 credits. Oh, it goes automatically. That's not the idea. It has 3 credits model-based system engineering. There is 6 credits already starting with your master project, where we dive a bit more into how do you do a literature study and how do you write a publication. Then there are 6 credits diving more deep into communication systems. It's more about the wireless communication and so on. And then 6 credits on software engineering. This is together with people from industry focusing on how do you build like a big software program using Agile or other methodologies and so on. Then more importantly, when you start at our master, you will have to choose between 3 majors that you can follow. The first major is a major on cyber-physical systems. It contains 2 courses in a total of 12 credits, really focusing on cyber-physical systems, but I will elaborate a bit more on that later. A second major is focusing on artificial intelligence. It's just one big course on different topics in distributed artificial intelligence. And then there is a third major, also 12 credits focusing on Internet of Things, more diving into depth in low power embedded software and communication. So now we are already at 39 credits that we have. For the remaining credits, there are still 6 credits in an elective package and then 15 credits in a master project. For the elective package, there are 2 kind of packages. The first package is you choose for the company. What is the company? It's a program where you learn entrepreneurship. So what we do there is you get to know a lot of a lot about engineering, but how do we translate what you learn into getting a product on the market? What is a business model? What is a market? What is marketing? How do you sell? Do you sales and so on? So it's a trajectory really focusing on getting products to the market and not only focusing on the technology itself. Another thing you can do is elective package 2. There you get a course on management. That is obligatory in that package. And then there are 3 credits left, and those credits you can spend on different widening courses where you get information that can be widely spread. There can be a business internship, you can do a business training, but there is also a course on climate change in the digital world. It's very interesting, focusing on what is the impact of climate change and how can we cope with it with our digital technology and vice versa. We have a course on computer graphics, we have a course on cybersecurity, and we have a course on prototyping. So as you see, it's broadening up the knowledge you have, and it's not really diving into depth. And then last but not least, there is the master's project. Of course, it's like 15 credits, really focusing on a specific topic where you have to submit in the end a master thesis or at least a paper on what you did, and then a portfolio that supports what you did, and that is evaluated by the promoter of that thesis. What is important in that master is that we use that credit system that says what the workload of a course is. And I talked about courses of 3, 6, and 12 credits. If you look at a credit, it means that one credit is like 25 to 30 hours of work. In many countries, this is only half of that. So it's important to understand that in total you have 60 credits for a year. It means that it's full-time working or that you're full-time working on your master program. It's not a half-time program. We stress that a lot because quite often we see that 60 credits in other countries in the world is just a half-time program, and we want to have or want you to have the right expectations before you start here. Regarding your master, you're also working very close to research, and for that it's important that you know that you will end up in an ecosystem of 3 very strong research teams, all with their different expertise, with whom you will be working together in your master thesis, but also in the different courses. First of all, there is COSYS Lab. COSYS Lab stands for Constrained Systems Lab, and what they do is they really focus on using embedded systems, model-driven technologies, and sensor processing for cyber-physical systems. What is a cyber-physical system? It's a physics-based system like a car or a crane or whatever that, based on sensors and software, you start controlling. So very safety critical, time critical systems. Next to that, you have ID Lab. It's the Internet and Data Lab. They work on 2 main topics, wireless networking and artificial intelligence. That are their main topics. So in that team, you can elaborate more on How do you evolve from 3G to 4G to 5G and beyond? What are the communication technologies that are state of the art and will change the world in the future? And next to that, they have fundamental research in AI algorithms and everything that is on that. And then last but not least, because it's my own research team, I'm enthusiastic about it, it's MFORCE. What it stands for Modeling for Sustainability. What we try to do is we try to use AI-driven modeling technologies to build sustainable solutions. We are very close to the application domain, so we try to change the world in a sustainable way by changing technology in autonomous transport, smart buildings, renewable energies, and weather modeling and climate change. And our idea is always when we create a delta for a company, money-wise, and can incorporate a delta sustainability-wise, then there is an incentive for the company to change the world, and that's where we work on. Those majors that I was talking about, 12 credits that you have to choose. There were three options: cyber physical systems, IoT, Internet of Things, or artificial intelligence. Let's zoom in a bit more on what that means. If you look at the majors, actually, the end of a program, electronics and ICT, engineering, technology, it comes all down to communication, the mechatronics, and the control. You can look at it at that. And when you look at our different majors, each of them is located in that domain. The first thing is cyber physical system. What you see there, it's really focused on the mechanics and how you can build electronics on top of that. And there is an overlap with what we do in control. How do you control those things in the end? When we zoom in a bit deeper there, then you see that the first course will be really focused, the global course will focus on two major things. First part will be embedded systems. How do you cope with embedded systems? How do you use them to steer or monitor the different parts of those things? And then a second part, equally important, is when we have those embedded systems, we get signals out. How do we translate the signals we get into actuation policies, actions we can take towards controlling those systems? So how do we translate LiDAR camera data into deciding that we have to stop a car? That's in essence what happens there. Yeah, when we zoom a bit deeper into those embedded systems, the important part there is that there is a lot of complexity in the constraints you're working in. Those embedded systems don't have the computation power of a large data center. They are small, they don't have the energy availability and so on. And there are the safety regulations. So there are specific development methodology, like the V model, for example, that they will explain there on how to build software for those things. And then when you look at the advanced system signal processing methodologies, again, we look at the signals, but we also translate it on how to get them ready on an embedded system for really controlling them. And how do we cope with different types of hardware? We will also focus on hardware programming like FPGA, but also include technologies like GPU, TPU, and so on to see how to cope with that. And finally, in that course, we will bring both worlds together in a project where, based on embedded systems, a global problem will be solved using different components like drones or other robotics, where those things will be built, doing signal processing, taking actions, and so on. Second major we have is Internet of Things. And as you see, it comes way closer to communication, and it includes also a bit of the control strategy. So what is the essence there? When you look at IoT, what it does is it gathers data from all over the world in a distributed setting, but there is always a constraint in the available resources to get those signals in. And in most cases, it's about the low amount of energy that is available. So there they will zoom into how do you write software that use the least amount of energy possible, and which communication methodologies are out there that fit the best, making a trade-off between the amount of data that you send and then the amount of energy that you use for sending that data. It's all about ambient intelligence. So what they want to do there is put different individual IoT devices out there, and then together in those surroundings create some kind of emergent technology that will generate new information. The two focus points there are low power, of course, as I said, but also context awareness. And most of the students starting in the master don't know that, but actually the technology that is used to do communication, like Wi-Fi or Bluetooth or Dash 7 or whatever, is also the technology that you can use to do localization. Main reason is it sends out signals for both purposes, and based on the signal strengths, the orientation, and so on, you can also do localization. So those two things will be in that thing, and then without everything we learn there, equally as in the other major, we will have a project in the end where, based on a lot of individual IoT devices, we will bring together information and get towards conclusions. Here there was a prototype a couple of years ago where we measured the amount of water that was in the sewers in Antwerp, just to know what happens when there is like a threat of flooding and which parts get a lot of water and where there is not a lot of water, to steer the firemen to the right location. And then for communication, we use existing technologies, but then we also use our own stack where we can build on top of that. And yeah, as I said, we have a project and then a part on the communication and the power. Then the last major is about distributed artificial intelligence. Of course, that is all about control, but it also incorporates the mechatronics because you have to control a system. So at least you need to know what the system is and how it works. And of course, we cope with distributed artificial intelligence, which means that they are distributed and for this have to communicate. And that is how we approach it. How do we do it? In that course, what we try to do is we try to build intelligence in a distributed context to operate in a world that looks more or less like this. So we have different agents in different areas, and how can we incorporate AI technologies, neural networks, learning methodologies, and so on in those components to together let them create some kind of emergent global behavior that solves what we have in mind. And when you look at the two previous majors, actually, that is where they come together. You have the global information of IoT, you have the very complex and constrained information of the cyber physical systems. The intelligence comes together in the middle, and based on all information, with different characteristics, we evolve towards data-driven control, and that is what we want to do in a distributed environment. Also, this course works on different modules. So there will be a deep learning module, there will be a simulation module, a data-driven control module. PhDs from the different research teams working on those things will show what they are doing. And then in the end, again, like in the other majors, there will be a big project where people together build these emergent technologies. This is not just built in simulation, but we have a lot of very cool test beds for that. So we have cars where we can get all sensory information in, do actuation on. We have like smaller cars. This is an F-110 car that we cannot let them drive autonomously and so on to test those things. We have similar things on the water. So I don't know whether you know Belgium enough, but there is a lot of inland waterways where we can steer autonomous ships. Next to that, of course, we have here in Antwerp a very nice digital twin of our city. And based on that, we can start dealing with traffic, real-time traffic forecasting, but steering as well, to go towards, fully distributed autonomous control of a combination of systems. That is the goal. So I think I gave the main message to you. We have this master you subscribe to. There are a couple of courses that are fixed. Then there is a small elective part that widens your knowledge a bit. Main thing you will have to choose when you start at our university is whether you're gonna focus on IoT, cyber physical systems, or AI. And next to that, of course, you will also need to decide what master course you want to follow. And then I think you can start. Last but not least, a thing that you need to remember is it's 6 credits. It's a full-time program. And now the floor is all up to you. You can ask me questions or send emails to the addresses that you see here. Are there any questions? Did I forget something, Kim? That's also important.
I don't think so, but it depends on what questions everyone has.
Hello, my name
Yeah.
is Taha, and I have one question.
Yes.
The major which we have to select, at what point we will select, like in the start of the degree or in the second semester, like when
Yeah.
will we choose that major?
We
What
start
will
the academic year with a welcome day, a welcome week actually for international students, and there's one faculty day, and that's basically where we're going to ask you what major do you want to do.
Yes, and it's
Uh,
important to know because that day we will start at a certain hour. I will repeat a bit of this presentation again, and then we will together with you try to decide what to do, or we give you at least the right information to take that step. So make sure that first faculty day that you're in time because that is the day of that week that you will have to take very important decisions.
okay, thank you.
Thank you for the question. Are there other questions? Feel free to ask. As you see, our university works in a very informal way, so it's all open. Don't hesitate. We are all peers within the university. That's how we see it.
Also looking forward to it and very excited to join the university.
Thank you very
Ah,
much.
we're looking forward to welcoming you. Did all of you already receive the letter of acceptance, or are some of you still in doubt whether to go to the next step of the application or not?
I have received the acceptance letter.
Okay. Kelvin as well, I see. Okay.
Don't be shy. You can use your mic as well to talk. That's easy. Then you get to know each other already. The people who feel comfortable can also put on their camera. Then you already see the other students that you will be studying with next year.
I want to confirm, right? Each section of this course, are they all 1 year or it can be 2 years?
Well, normally the entire master program is 1 year, but obviously if you don't pass all courses the first time, you can extend it to 2 years.
And
All right.
what you
So
can also decide, Kelvin, if that is an idea you have in mind to take it up half time and then go to work half time, for example, or is that impossible, Kim?
It depends. For European students, that's possible. For
Okay.
non-European students, you have to enroll in the 60 credits to for the student visa. So the visa requirements are that you take a full-time program. Yeah,
all
so
right. So
that's a bit of a
during
difference between European and non-European
I'm
students.
sorry. Wrong information from my side. That's why Kim is here, of course.
So the reason why I am asking is because I would really love to have an extensive study in the course. So
Mhm.
some I kind of feel like 1 year is kind of like too short to study a course. So I don't know if there are other measures in place to ensure that students have a more practical experience while studying. That I don't know if there is like an internship or something around the school premises where students can have like hands-on practices.
Well, you have an internship during your master thesis. Um, the program is already very practical. It's a combination of theory and practice. So it is already in depth. Also, although it's only a year, it's a very in-depth, intense program. So don't get mistaken by the duration of the program. It is very intense and it's very in-depth. We've noticed that most international students do take 2 years to complete the course because it is a lot. It's a lot to adapt to a new way of studying, a new program, a new environment. So it might take 2 years to finish it, but it's not it shouldn't be the goal in the beginning.
Yeah, and I think what Kim said is very important. If you look at our program, the theoretical part is in depth and strong, but next to that, the practical part from a time perspective is larger. So what we try to do is we try to go in depth in certain techniques, fast and deep, and then we let you apply that in multiple projects. So when I was talking about software engineering or signal processing or whatever, it's all supported by practical sessions or projects where you learn in depth what you learned in the or in depth in practice what you saw in the theoretical part. So for example, in distributed artificial intelligence, we will learn you what the different kind of reinforcement learning, it's a type of machine learning techniques are, what the different aspects are, and then you will apply them in practice on certain toy examples, like creating a chess system, for example. And then in the next step, we will go further and say, okay, now it's up to you. You know the techniques. We have this bigger problem. How will you use it? And then it's up to you to apply it to that specific application domain with your peers together, of course, at that moment that we bring all of your brains together to make a difference.
All right, thank you.
Hello, I have a question here.
Great.
Should.
Uh, Actually, I'm confused because normally the master is of 2 years, but this master is for 1 year. For example,
Yes.
I graduate within 1 year. Will that affect my in getting a job or something like that? Or if I want to pursue my education to the PhD, will this affect the 1 year? Because
No.
No,
normally
In
no.
Belgium, it's
master.
actually, you've got some masters are 1 year and some masters are 2 years, but they're all academic masters and they all give access to PhD positions. So that's not an
Yes.
issue.
And even PhD positions in other faculties as well. So if you want to get a PhD position in a faculty where there are 2-year masters, you're still allowed to apply there and start your masters. And we see that a lot. Um, Actually, I think it's one of the benefits that we have that in a very short but high quality program, we prepare you to do a PhD or we prepare you to start as an engineer because you get your degree of engineer in a company.
You also get the engineering title after finishing the master. So it's
And
not, yeah.
and if it is about having a job in Belgium and you're afraid of that, every year I have a lot of problems finding PhD students as companies come and get you out of the program because the amount of electronics and ICT engineering profiles industry needs here in Belgium, close to the port, because we are close to the biggest or the second biggest port in Europe. Yeah, the demand is very, very high.
And also, does the university help students to get jobs, like getting a job?
You mean during your
Sorry?
studies or
No,
after your?
after a degree.
If that would have been necessary, we would do that. But it's not necessary at all. But of course, it's more necessary for other engineering degrees. So we have every year like a big event where like, yeah, 50, 60 companies come there. You can go and talk to them, ask what they do, but it's not necessary. You will see during your program, you will get into contact with a lot of connections and you will have a job before you graduate. That I can promise you.
Yeah, and for international students, there are a couple of information sessions about working in Belgium, because there's an option to extend your visa with 1 year. It's an orientation year, it's called. So you have, after you've finished your degree, you have like, you can extend your visa for 1 year, which is the year you can search for a job. So there's information sessions about those things. And then, as Peter said, there's the Engineers of Tomorrow, which is sort of a fair where where a lot of companies come together and our students get in touch with the companies. But it's not the main issue for our students. I think it's fairly easy to find a job.
No, not at all. Are there other questions? There were some students who did not ask anything yet. Feel free to do so. Europe is a bit atypical in that sense that the distance between a student and a professor is not that big. So just ask what you want to ask. Even if you think maybe it's a stupid question, still do so, because there are no stupid questions.
Maybe also important for you guys, once you've got your letter of acceptance, you will get certain mails from our international students office. So they will send you mails during the summer about housing, about welcome week, about health insurance, and stuff like that. So you will get all the information about practical information about living in Antwerp will be sent to you in several emails. So you get some newsletters that give you all the information you should need. Maybe I'm just curious, are there students who are still in doubt whether they would join the program or not? Are you all convinced, or are you still? Because Taha, you still seem to have a bit of a bit of doubt.
No, I'm not in a doubt. Actually, I'm already in Belgium. I'm living in Brussels.
Okay.
For like 1 year.
Yeah.
So I will be joining the degree.
Anyone else still have doubts we might be able to take away?
Maybe ask every student. Hirma,
Hirma.
what do you think? What is your status? It's difficult to answer at the moment. You can also type it, if that is more convenient. Kelvin, I suppose you were enthusiastic?
Yeah, I don't have any other questions to ask.
Okay,
And I'll present the program.
great. Darren, do I pronounce that right?
Hello, sir. Thank you
Hello.
for your presentation. Actually, I am driving right now. I
Okay.
just want to listen to you. Thank you for everything. I have no question.
Okay.
And are you still doubting to come to Antwerp, or are you already certain that you will come?
I will be coming from Turkey.
Okay, great.
Okay, great.
Yes.
And then there is Mohammed. What are your thoughts at the moment?
Yes, I will be joining the program. I will come from Pakistan.
Okay.
Okay,
You will
great.
not be the only student from Pakistan.
Yes, I have seen emails which you sent us. In there are many Pakistani students.
Yeah, yeah. Taha, you're from Pakistan as well, no?
Yes,
Yes,
please.
yes. So I'm also from Pakistan.
Okay.
Uh,
Okay.
Great.
You've got my email address. You've got Peter's email address. Don't feel shy to contact us if you would have any more questions. Feel free to ask us, and we'll help you out. And if there's no more questions, then we
Yeah, and
would
if
like to
chat
see
is
you.
more, if chat is more convenient, now you have our Teams accounts as well. You can also send me a message on Teams if that's more convenient.
And then we really hope, we're looking forward to meeting you at the end of September. There's going to be a welcome week for international students. And then during that week, there's also one day at the faculty, and then you'll see us again.
Probably on
Hopefully.
Wednesday, is it, Kim?
Yeah, Wednesday or Thursday. I'm not sure yet. I have to check.
Okay. Make sure that you are there at that day, because I know it's a lot of new things and a lot of things to arrange, but that day is very important. Certainly that information session in the beginning, because there we need to decide about the majors and about the elective courses. And I need to explain you about the master thesis that you will have to choose as well. So then I can connect you immediately to the right people in the program to start working together. Then we don't lose time. And as we know, a year seems to be long, but it goes fast. And the sooner we can start, the more quality we can have.
Okay. Thank you all for joining. And see you soon.
See you. Bye-bye.
Bye.
See you.
Bye.
Thank you. Bye bye.
Bye.
Bye-bye.